about. You see, in everyday life, when we talk, when we have a conversation, we usually starting with a line of argument, and at the end, we would like to arrive at a conclusion. So we want to know from the logical point of view, what is going to be a valid argument, valid conversation. Okay, so that would be very important, because then you are going to use it for for proving theorems, and we want to make sure that it's correct. And you'll be surprised when you say this type of results. Okay, so this is going to be section 2.2.3, the last section from chapter 2. And the idea is what is going to be valid, valid arguments. So what are going to be considering to be a valid arguments in logic? So we have some expression to go. There are going to be some line of arguments that we start, and there is going to be a conclusion. So a valid argument, a valid argument in any conversation is going to be a finite set of set or collection, collection of sentences or propositions This is where we start talking. Okay, so it's going to be a finite set. 2, 3, 4 is a finite set of propositions that we start to, and we're going to call them P1, P2, whatever it is, Pn. Okay, these are going to be called the proposition that you start with. We're going to call them premises. Okay, that's going to be called. This is going to be premises of your argument. Okay, so you start with a line of argument, then there's going to be a conclusion together. Okay, it's going to be together with a result, with a proposition, the result, we call it C for conclusion. Okay, that's going to be called, this is going to be called the conclusion of your argument. Okay, so that's going to be conclusion. So it's going to be premises, the line of the argument, and the result. Now, so where are you, or how are we going to consider it's going to be valid? This is the line of the argument, and this is going to be the conclusion. Okay, now such that to get a valid argument, such that this implication, the conditional implication, such that the implication that if you put them together, implication that if you have the P1, and the P2, these are your line of arguments, etc., getting to the Pn, that would imply C. This is a conditional implication. It can be true or it can be false. We are going to call the argument a valid argument if this is going to be always true. You know that if a statement is always true, in that case, it's going to be called a tautology. So such that this implication is always, it's going to be always true. Or it's going to be as you know it, it's going to be a tautology. Okay, this is going to be a tautology. So in that case, the expression that we're going to use, in this case, when the argument is going to be true, in this case, we are going to write, we write, when the implication is always true. We did this one or some other argument before. So we write the P1, and the P2, and the Pn, When we want to say that this is going to be a tautology, as we did it before, we're going to use 2 lines here. Okay, this is going to be the one. Okay, so if you have a line of argument that we're going to call them P1, P2, P3, and you arrive at the conclusion, okay, you arrive at the conclusion, then this implication over here is going to be always true. If it's going to be always true, your argument is valid. If this is false, your argument is not going to be valid. We call it invalid argument. When it's a valid, it's a tautology we already talked about. We just use double line over here. So you start with this one, but you may use truth table or some other reasoning to show that this is going to be tautology. And this is your job. You list the P1, P2, the line of argument, and you list the conclusion, you put them together. Then you are going to use some reasons to prove that this is a tautology. The easiest one is going to be just a table. You can use the truth tables to get it. There are some shortcuts. For example, this is AND combination. You know that if one of them is going to be false, if one of them is going to be false, so this would be false. An implication that start with the false is always true. So you can use this type of facts, to get it. Okay, so I just remind you this one. This would be useful sometimes. It's safe as sometimes. Okay, so just remind you that automatically you know it, but remind you, note that if one of these, okay, one of the line of argument or premises, okay, one of these premises, P1, P2, up to the Pn, one of them is going to be false. If one of them is just false, then you know that the implication is true. Then we have a valid argument. Then we are going to have a valid argument, This would help you sometimes, to save time to get these numbers. Okay, any question? So that's the foundation, that's the base. You're going to use this base to find out. There is another notation for this type of arguments. Some people like the other one, and you have some problems in your book. So we give you that notation too. And then we're going to check this one with some cases. You get the idea. Okay, there are some popular cases. Put them together 3 or 4 cases. So we give one example from each, and then you'll be fine and be done. There is another notation that they call it inferential form. Okay, just in case you see it, you know that it's going to be the same thing. You see inferential form. Inferential form would be the same thing that we did, but this notation. So a logical, okay, the logical argument. You have the logical argument with these premises. Okay, with the line of argument or premises P1, P2, up to the Pn, depends how many lines of argument you have. Okay, and the conclusion. Okay, and the conclusion C, conclusion C, it can be denoted in inferential form. Can be denoted, okay, by the following. They call it inferential form. By the following, okay, inferential form. So you can use either notation, but sometimes, especially the second one would be given to you and they want to prove and you want to write on short form, they use this one. So we want to make sure you know it. Okay, this is one format. They write the line of the argument is vertical form, P1, P2. This means if you give me P1, P2 up to the Pn, then therefore, you say this is it, therefore C. So you realize these are going to be the line of arguments and the C is the conclusion. And if you want to prove it, you have to prove that the P1 and P2 and the Pn and the C implies C is going to be what? Is going to be a tautology. Okay, so it's just a notation, or sometimes they use this notation. We use this one, P1 and P2 up to the Pn. So this means if I have all of them, then that would imply a C. You know that with the double line means this implication is going to be always true and it's going to be a tautology. Okay, so you can use either one, and if it's given to you, you are ready to read it. Okay, so there you are. You see, these are all means the same thing. That's it. This one and the other one over here. Even if this is given to you, you have to form this format to check to see if it's going to be tautology. Okay, now the examples are going to be a line of argument would be introduced. You change it to the symbolic form. You may use the table or sometimes algebra to prove that whether that argument is going to be valid. This is going to be your job. Okay, any question? Let me write the example to see how we're going to take care of this. There are some very common ones, so I give you those, and most of the problem are going to be of this format. Okay, so let's have the first one. This is going to be our example. And we give you 2 problems, 4 cases for your next test on this one. Okay, so we want to determine if the given argument, okay, given argument is valid. Okay, that's going to be one. Let's check the first one. This is how we're going to argue with you. If John, that's the first line of argument. If John has a B in calculus, okay, has a B in calculus, he will graduate. Okay, he will graduate. Okay, this is first line of argument. The next one is, the next line of argument is John. Okay, John does not, or does have. Okay, John does have a B in calculus. A B in calculus. Okay, this is the second line of argument. Now the conclusion. The conclusion is that therefore, okay, therefore he will graduate. He will graduate. It's a very popular one and easy one to check. Okay, so this is the problem. Remember, you have to change it to the symbolic form first. Okay, change the symbolic form, then you argue, because you have to identify the premises and then the result. Okay, are you ready? Solution. Symbolic form, you see, John has a B in calculus. We call this one something like P. This proposition, we call it P. He will graduate, we call this one Q. Okay, so the first part is going to be if P, then Q. So the first part would be if P, then Q. That's your first line of argument. Any question? The second part, John does have a B in calculus, which is P again. Okay, so, and P. Then the conclusion. What is the conclusion? The conclusion, I just use this notation. The conclusion is therefore he will graduate. He will graduate means Q. Okay, so you want to see if that would imply Q as a tautology. When you prove it, you change this one into the 2 lines, okay? But this is going to be the case. Okay, any question? So you put them together. This is, this means if P, then Q. If you give me P, I will get the Q. I've already given you the P, so I should get the Q. You see, that's a line of argument, but we have to prove it. So in your book, they use some Latin expressions for each of one of them, but we want you to do it for us, okay? We want to just show us what is the meaning, how we're going to set it up. Okay, don't memorize anything. So just do the symbolic form. So the conclusion is going to be, you know that you just remind yourself that the argument, okay, so the argument is going to be valid. Just explain this first one. Is going to be valid if, okay, that's it. Your first premises is this one. If P and Q, that's a P1 if you like. And the next part is P. Is P, okay, implies Q is going to be, is a tautology. Is going to be a, okay, tautology. That's what we have to prove. Okay, any question? So each part is going to be one line of the argument. So it's a P1 and the P2. So the best way to do it is just to draw a table, very safe one. You draw a table and you check to see if this is going to be always true. So this is going to be a table. So I need a P and I need a Q. Then I need a P, if P, then Q. That's a P, then Q. Okay, so then I need if P and then Q and P. Okay, and then I need the conclusion. So the conclusion is that if P then Q and P implies Q. You see, this is going to be your table. You have to prove that the last line is always true. Okay, and you know the cases that we're going to have. So the first case is going to be, this is going to be true, true. Okay, P and that would be true. Okay, P is true and this is true, that give you true. Okay, the first part is true and it's going to be true. So the first one would be true. And then you consider the other one. If P true, false. Okay, true, false, you start with the true and then end up with the false. You know that it's going to be false. And since the first one is false, this is going to be false. And the first part is false, so this is always true. That's the second part. Okay, and you continue, it's going to be false, true. So in case of the false, true, you start with the false, this is always true. Okay, and this is true, and the P is false, so this would be false. And since you start with a false statement, this is always true. The last one is the same, false, false. So you start with the false, it's going to be true, and this is going to be false, and this is true. So this is always true. So this means the argument is valid because it's a tautology. Okay, so the argument is going to be a valid one. This is how we are going to do it. Okay, so be precise and write everything nicely together and just give us the table, and then we'll be happy with this one. Okay, any question? So we need, a couple of more examples. Let's see if we can give you one more. Okay, the next one is very popular, and you don't need any table for this one. So let's check another one quickly, and then we continue. We need to give 4 or 5. We need 4 different cases. Okay, let's try this one. What is the line of argument? If Harvey is a dentist, he is going to be a dentist, and then he or Harvey, Harvey drills. Harvey drills teeth. So that's going to be the first part. Okay, if it's if he's if it's a dentist, he will do his job. Okay, it's the second part. The second part is Harvey does not derill it. Harvey, okay, does not derill it. That's a second line of argument. So what's going to be the conclusion? The conclusion is therefore Harvey, okay, Harvey is not a dentist. It's an easy case and it's very popular. That's it. Okay, if Harvey is a dentist, you may call it P. You have to change it to the symbolic form. Okay, Harvey is a dentist. You may call this one P. And drills a teeth. You call it Q. So over here, Harvey does not drill the teeth. So this would be not Q. Not Q. Therefore, Harvey is not a dentist. It's going to be not P. Okay, PQ, PQ, not Q, not P. Now what's going to be symbolic form? If P then Q, if P then Q. That's the first part of the argument. The second part, not Q. The conclusion, okay, the conclusion is going to be not P. You see this one? So this means if P is given to you, get the Q. Now you'll be given not Q. So you want to conclude it implies not P. It's very easy. Remember the contrapositive property? The contrapositive property will give you that if P then Q, remember, is equivalent to the not Q implies not P. So you change the first one into the not Q implies not P, and you get it by the contrapositive property. And you don't need any table, nothing, okay? So what we have to prove over here is, so this is going to be the question. The question is that if P then Q and not Q implies not P as a, okay, as a tautology. Now you have to explain it. You say, oh, note that by contrapositive law, if P then Q is equivalent to the not Q implies not P. You see, that's one. So what you have, you see now you have to, you change it into that. So the first one would be a not Q implies a not P, and the not Q here. So this means if I give you not Q, you give me not P. I've already given you not Q. So that would implies not P. Okay, so you don't have any to draw any table for this one because we use the contrapositive property. Okay, so we just mentioned that by contrapositive law, the argument, okay, the argument is going to be is valid. It's a very popular case. And as soon as you see it, remember, you have to do this symbolic form. On the test, you get points for it, okay? So you have to write the result in symbolic form. And that symbolic form, okay? So this is going to be the one. So if P not Q is the first one, not Q implies not P. So what we do is we change the first one into the equivalent form. If P not Q would be the same as a not Q implies not P. So this means if you give me not Q, I give you not P. Otherwise, I got the not Q, so I get the not P right away. So by contrapassive property that give you, okay, that give it 1. There are a couple of more. We talk about it. Okay, this is it. Is going to be, yes, it's going to be Monday. And we finish this one, this chapter. So we are done almost with chapter 1 and 2. Chapter 3 is going to be quite interesting. We are going to bring some very famous symbols or the methods that we can describe all the problems in mathematics. We do that one quickly, we finish it so that we can get to the chapter 4. Okay, that's it. Any question? So make sure you submit your assignment by tonight. You know that. You submit your assignment so we can get your point. I quickly check your quiz because we want to know how you write it down. Sometimes your writing is not going to be the way we like it, so that we can get, you know, we can get an idea, and then we continue. It will be getting more interesting as we go on in this next chapter. So as we talk about it, we build up the language. This is we going towards the how we are going to prove the. You see, we put these together, we get a mathematical system. Then the question is going to be how we're going to prove those systems, theorems, etc. So we need to finish chapter 3, and then we get to the 4. We may give you a little bit of 4 for your test, but otherwise we'll be in that chapter. Okay, that's it. Any question? Have a good one. Make sure you submit your assignment for tonight. It's 10 points. And see you on Monday. Bye-bye.
Thanks, see you Monday.
Professor.
Thank you, Professor.
Thank you.
Okay, bye.
Thanks.
Okay, thank you. Just